In this video, we're going to talk about the half angle identities. So first, let's write down what our identities are. So for sine, our half angle is going to be plus or minus the square root of 1 minus cosine of x over 2. Cosine is going to look very similar, except for it's going to be 1 plus cosine of x over 2. And then tangent is going to have three options. One of them is if I did sine divided by cosine, so I'm going to have plus or minus the square root of 1 minus cosine over 1 plus cosine, or sine over 1 plus cosine, or 1 minus cosine over sine. So we can use any of these three options for tangent. The plus or minus is going to relate to whether that value is positive or negative in that quadrant. And so we'll talk about that a little bit more. So in this case, I want to find the sine of 75 degrees. So I want to think about what would be 1/2 times what would give me 75 degrees. So 1/2 times 150 would give me 75 degrees. So I'm going to have plus or minus the square root of 1 minus the cosine of 150 degrees divided by 2. Now, if I'm talking about 75, this is in quadrant 1, and sine is positive in quadrant 1. So we're going to use the positive square root. And then do 1 minus, well, cosine at 150 degrees is negative root 3 over 2. And so I'm going to have 1 plus root 3 over 2 over 2. Now, I just want to simplify this so I don't have a fraction within a fraction. I'm going to do that by multiplying by what's in my denominator. I'm going to multiply by 2. And so I'm going to multiply each of these by 2. And what that'll give me is it'll give me 2 plus root 3 over 4. Now 4 is a perfect square, so we're going to have 2 plus root 3 all over 2. And so this will be my final answer. Similarly, for cosine of 7 pi over 8, I want to think about if I do cosine of 1/2 times what would give me 7 pi over 8. And the answer is 7 pi over 4. So we're going to have plus or minus the square root of 1 plus the cosine of 7 pi over 4 over 2. Now 7 pi over 8 would fall in quadrant 2, and cosine is negative in quadrant 2. So we're going to end up with the negative square root of 1 plus, well, the cosine at 7 pi over 4 is root 2 over 2. And so we're going to have 1 plus root 2 over 2 over 2. Similarly to the problem above, I want to get rid of this fraction within the fractions. I'm going to multiply by 2. So I'm going to end up with 2 plus root 2 all over 4. And again, that 4 is a perfect square, so we end up with square root of 2 plus root 2 all over 2 is my final answer. Now we're going to go about this in a similar way with tangent. So I'm going to say, all right, tangent of 1/2 times what would give me 112.5. And the answer is 225 degrees. So now tangent, we have three options. Typically when we're solving, I'm going to use this guy or this guy just because there's not a square root. I don't have to worry about the plus or minus. Oh, and I totally dropped my minus along the way in this one, didn't I? Yep, there should be a negative there. Sorry, guys. All right, so now with tangent, I'm going to use either this second one or this third one. I may like to use the third one because there's only one thing in the denominator. So I'm going to do 1 minus the cosine of 225 divided by the sine of 225. And so I'm going to have 1 minus negative root 2 over 2 all over negative root 2 over 2. And so I'm going to have 1 plus root 2 over 2 over negative root 2 over 2. So both of my denominators in this case are 2. So I'm going to multiply by 2, and that'll get me 2 plus root 2 all over negative root 2. Now in 4 and 5, we're going to compare these to our formulas at the top. So I'm going to zoom out a little bit. So if you look at number 4, it looks a lot like this tangent half angle. And if you look at 5, it looks a lot like this cosine half angle. So if this is the same as the tangent half angle, we're going to say, well, this is the same as the tangent of 1/2 of theta, which is 10x. So this is the same as the tangent of 5x. Similar with this one, this is a cosine half angle, so half times theta, which is 8 theta. So this will simplify to cosine of 4 theta. Now, just like we did a sum and difference and doubles, we are going to draw a triangle. So if I have sine A is -3/5 and cosine A is greater than 0, sine is negative, cosine is positive. That happens in quadrant 4. Sine is opposite over hypotenuse, and this is a 3, 4, 5 triangle. Now, to find the cosine of A over 2, I would do plus or minus the square root of 1 plus cosine of A over 2. Now, to figure out if this is positive or negative, I need to think about where the half angle would fall. So A right now is falling in quadrant 4, which is between 360, or between 270 and 360. Now, the half angle would then fall between 180 and 135. And so if I'm trying to find the cosine half angle, 180 and 135 would fall right here. Cosine is a negative number in that spot. So we're going to use the negative symbol in this case. So I'm going to have the negative square root of 1 plus the cosine, which is 4/5, all over 2. Now, 1 plus 4/5 is 9/5 because 1 would be 5/5. So 5/5 plus 4/5 would be 9/5, all over 2. Now, 9/5 divided by 2 is the same as 9/5 times 1/2. So we're going to have negative square root of 9/10. Well, 9 is a perfect square, so we're going to have -3 over square root of 10. Now, if you wanted to rationalize it, you could write it as -3 root 10 over 10, but either answer is fine with me. Similarly, in number 7, they say tangent is positive, but now we're falling between pi and 3 pi over 2. So that's in quadrant 3. And tangent is opposite over adjacent. But now we're in quadrant 3, so remember, my x and y are both negative. So even though tangent's 1/2, tangent is positive because a negative over a negative is a positive. But both of my x and y are going to be negative, and my hypotenuse is going to be root 5. And I would get root 5 by doing 1 squared or -1 squared plus -2 squared equals, r squared or h squared or c squared, however you want to label that hypotenuse. So I'm going to have 1 plus 4 equals r squared, 5 equals r squared, so r equals square root of 5. And now r is always going to be positive, so I don't have to worry about the plus or minus. If I'm going to find sine of the half angle, that's plus or minus 1 minus cosine over 2. So again, I got to figure out if it's going to be positive or negative. So if x is between 3 pi over 2 and pi, then if I multiplied all of this by 1/2, I would get that the half angle is between pi over 2 and 3 pi over 4. And so that would put us in quadrant 2, and sine is positive in quadrant 2. So we're going to use the positive. So I'm going to have 1 minus, well, the cosine of x would be -2 over root 5. So I'm going to have 1 plus 2 over root 5 over 2. Now, I want to get rid of this fraction in the top, so I'm going to multiply by what's in the denominator, which is a root 5. So I'm going to have 5 root 5 plus 2 all over 2 root 5 as my final answer. Now we have one more thing to talk about, is just verifying an identity. So they want me to use the tangent half angle right here, and I have to figure out which one to use, knowing that I know cosecant is 1 over sine. So if I think about my options for tangent, it is 1 minus cosine over 1 plus cosine. It's sine over 1 plus cosine, or 1 minus cosine over sine. Since I already have a sine in the denominator and I know I want a 1 plus cosine in the denominator, I'm going to use this middle option. So again, thinking about when you have multiple choices, what's the best option to use when it comes to simplifying? Because now my sines will simplify and I'll be left with 1 plus cosine in my denominator.